You aren't getting wet from the rain. You are drowning in your own sweat because the thermodynamics of your jacket just failed.
The outdoor industry sells a paradox, a fabric that blocks liquid water from entering while allowing water vapor to escape. Under laboratory conditions with a massive pressure differential, this works. In the field, it is a ticking time bomb. Membranes rely on a diffusion gradient. Moisture flows from high heat and humidity, your skin, to low heat and humidity, the outside air. This is Fick's law of diffusion. But this flow only exists when the outside is drier than the inside. This leads us to the failure point, wetting out. Your jacket has a DWR, durable water repellent, coating that increases the contact angle of water droplets, forcing them to bead and roll off. This is essential for the membrane to breathe. Dirt, body oils, and abrasion degrade the DWR. When this happens, the face fabric absorbs water. This creates a solid wall of water on the outside of your membrane. The humidity differential drops to zero. Physics dictates that breathability stops immediately. Once wetted out, two things happen. First, your sweat is trapped, creating an internal sauna. Second, the wet face fabric becomes a conductive thermal bridge. Water conducts heat 25 times faster than air, rapidly sucking heat away from your core. This is why you feel wet even if the membrane doesn't leak. It's called condensational dampness. The marketing hype focuses on hydrostatic head, how much water pressure a fabric takes before leaking. But for high-output activity, this number is often irrelevant compared to MVTR, moisture vapor transmission rate. Let's look at the pressure reality. A standard 20,000 millimeter waterproof rating is overkill for rain, but necessary for pressure points. However, no membrane can handle the vapor output of a human working at threshold. If you are bikepacking or moving fast, aerodynamics and body position complicate this. The crouched posture compresses the front layers, reducing the air gap needed for moisture transfer. You overwhelm the system faster. The solution is mechanical venting. Pit zips, chest zips, or a poncho allow convection to bypass diffusion. You are physically exchanging the air mass rather than waiting for molecules to migrate through plastic. For extreme cold, below freezing, we invert the logic with a vapor barrier liner, VBL. You wear a non-breathable layer next to the skin. This stops sweat from entering your down insulation, where it would freeze and collapse the loft. The VBL keeps your insulation dry and stops evaporative cooling. You stay warm in your own microclimate. It is uncomfortable, but in -20 degrees, comfort is secondary to survival. Manage your output. Be bold, start cold. Don't wear the shell unless you absolutely must. If you rely on a chemical coating to save you from hypothermia, you have already failed the systems engineering test. Trust mechanical ventilation, not chemical marketing. Stay dry.